Morning all. Today we are going to discuss in this particular lecture video mitigation of narrowband and broadband fading. Mitigation of narrowband fading. What exactly meaning of this? The effect of unmitigated fading we have to understand. The probability of bit error rate is the principle of metric of interest for the physical layer of a communication system. For a QAM based modulation system, the BER in additive white Gaussian noise can be accurately be approximately by the following relations. This is given, where m greater than or equal to 4 is MQAM, probability error decreases very rapidly with the SNR, signal to noise ratio. Since the channel is constant, the BER is constant over time. However, in a fading channels, FER becomes random variable and that depends on the instantaneous channel strength, and M level modulation given by equal to M SNR equal to PB. For fading channel, BER goes down very slowly with SNR, only inversely, that you can see here. Flat fading causes the loss of least to 20 to 30 decibel at the reasonable BER value. Conclusion, you can see up there QM, 16 QM and 16 QM, these three OFDM technology we are using in LTE. That you can see for separating a link and downlink and etc. Conclusion from the figure in the original system BER like 10 and 6, the required SNR is over 30 decibel higher in fading. Clearly, it is not desirable or even possible to increase the power for over a factor of 1000 to overcome occasional deep fades. Spatial diversity. When we have discussed, there was a fading, there was a losses of the transmitting wave transmissions, propagations from one antenna, transmit antenna to the destination antenna due to reflections of the signals or scattered signals that takes place multipath at the receiver that causes the fading. But the signals is getting spreading, that also causes the fading effect on the receiver antenna, and that we are going to discuss in the spatial diversity technique that can be used for the correcting the things for diversity technique to correct this particular fading. Diversity is the key and potential technique to overcoming the fading problems in wireless channels and to improving PER and BER. It is also known as antenna diversity and usually is achieved by having two or more antennas at the receiver or the transmitter. The spatial diversity is a powerful form diversity and particularly desirable since it does not necessitate redundancy in time or frequency. The simplest form of space diversity consists of two receive antennas where the stronger of the two signals is selected, but natural. It is so that we are using two antennas at the receiver. As long as the antennas are spaced sufficiently, the two receive signal will undergo approximately uncorrelated fading. So that also we have to take the distance between at the receiver end to be antennas has to be kept properly so that it should not be correlated each other with the frequency. This type of diversity is essentially called selection diversity and is shown in down. You can say selection diversity. Here, how it is most sophisticated form of spatial diversity include receive antennas array. So multiple antenna we call it array because this is two or more antennas we are calling array. With the maximum ratio combining and transmit diversity using space-time codes, transmit pre-coding and other combinations of transmit and receive diversity. Spatial signaling techniques are so important ultimate success for the LTE. That is the best technique is used for in LTE, spatial diversity technique to come over the fading effect of the space signal spreading. That's all today. This is the end of my video today. Thank you very much. We will discuss the entire things later on for how exactly the error is getting corrected at the receiver end, from the signal is getting transmitted from the antenna, transmitting antenna. If error is there in the packet, then how it will be corrected automatically, that is ARQ. And that we are going to discuss next slides. Okay, thank you very much.